Nearly everything we do is driven by code. Every line you write, or don't write, makes a difference. The choice is yours.
Okay, welcome everyone to my session. This is a JFall session, fixing your performance and concurrency bugs before they bite you. My name is Jeroen Borgers. I'm working for Rabobank and I'm a Java performance consultant. Today I want to talk about performance concurrency bugs and how to fix them. And these are extraordinary times, so we do this virtual, this session, but I'd always like to get some interaction with the audience. So what we're gonna try out is doing polls. So during presentation, I'm gonna ask you a couple of questions and you can react in polls. So before I start presentation, let's try that out a little bit. We do a test poll now, and you can react to the poll and get a little bit familiar with it, so it won't be distracting you from the presentation. So here's the poll. I hope it's working. You can react. Okay. Good. Hopefully it's working. And we'll continue with the presentation. So this the presentation talks about performance, especially at the Rabobank, what we do. And performance is very important there. Because of we get a high load. It's like 10 million balance retrievals a day on the active days and 10 million transaction overviews per day. And it's these days mostly mobile now. It's more like 7 times more mobile than web traffic. Yeah, and the users, they expect a quick response and high availability, always on, and of course confidentiality. And what does it mean? Well, for quick response, every 10 milliseconds counts when we develop our software. And high availability means that every crash or hang risk counts as well. So we should defend against that. And confidentiality, with high loads, we want to avoid mix-up of data. So every mix-up risk counts. Yeah, and the pains we have had with performance and accuracy, for instance, can be slow website, slow app, payments which are executed either twice or not at all. Can be data breaches, meaning one customer sees data of another one, crashing servers, in strange ways. And these are painful for the user experience and painful for the reputation of the bank. And these production bugs, they actually bit in a painful way. So what we do is we test with high load to check for response time, high availability, and confidentiality. And then if we find the pain, which response time is not good enough, for instance, then we hunt the bugs and we fix them. And there are different ways of hunting. You can look into the code. Yeah, is that a good way of finding your bugs? Performance and concurrency bugs? Well, usually not. So there are more effective ways with profiling, garbage collection analysis, or heap analysis, for instance. To show you a little bit about those ways of hunting, you can do profiling, for instance, with VisualVM, and you can find hotspots, the methods which take the most time. You can use more fancy tools like Dynatrace, AppDynamics which are commercial. Yeah, and they help you to find the bottlenecks in time. And yeah, we can do heap analysis, memory usage, find out where all that memory is consumed. And we can do that with a tool like Memory Analyzer tool, MAT, and quickly find where most memory is used by, and that's how it should be. And then for garbage collection, they can slow down your responses when they give a stop the world pause. And by analysis and improving that, for instance, here we have a graph where we see in production that the maximum GC pause time dropped by configuration setting from 7.5 seconds to below like 3 seconds. And we've seen cases where pauses were like minutes, and we could reduce that to below seconds. So yeah, and this work, this tuning and testing and hunting, that has its limits. It takes quite some time. You cannot test every possibility, every case, and you cannot hunt everything. And in continuous delivery, we actually want to deliver more quickly, release more quickly. So this means that you're also releasing those performance and concurrency bugs into production. And yeah, these type of bugs tend to hide and wait for some time to attack you when you don't expect it. And also in ways you don't anticipate. And then they're difficult to catch, because sometimes they're there, and most of the time they're not there. And yeah, so when do you want to fix those bugs? Yeah, here you see results of research where it's clear that most cost will be when the bugs are in production, and there's far less cost when you do this more early. So what we want to do is kill the bugs at the source early. And how do you want to do that? We identify the pain, hunt the bug that bites, and understand that bug. And then we want to build immunity against the bug. So we want to create detection at the source, and then let you kill the bug at the source. And then we want to share the immunity so everyone can benefit. So how do we share the immunity? Well, we do this by GitHub. And there's a repository, PMD JPinport rules, where we have this. And we share the understanding of the bugs, and we share the detection of the bugs. So you can kill the bug based on the detection. And how is this different from existing detections? So SonarQube has check style, FindBugs, PMD in it, different tools. Each provide their own checking rules. However, for performance concurrency, we found it to be quite limited, and also limited on the checking for various frameworks we use. And they don't work on our own or commercial frameworks. So it turned out that so you can call it existing immunity. It fails on the bugs we found. So many bugs come through and are not catched by the existing detection. So that's why we created our own detection, additional detection rules for better immunity. And actually, we had contact with the PMD team, and they incorporate already a few of our detection rules. So for understanding the bugs, you can find on GitHub quite some documentation which describes different categories of observations with the problem and the solution, performance concurrency wise. So that's all described there. And we use them in Sonar as custom rules. And you can find also there the documentation and it links to GitHub. And it's described how to kill the bug. So this is helpful from Sonar. So actually, where do you want to detect the bugs? And you have the process of coding, building, and then pipeline. And you actually want to do it on multiple places. You want to detect while creating the source. That's the quickest way, direct feedback. And you also want to enforce it at the quality gates in your pipeline. So to be sure it doesn't pass through. And for detecting at the source, we use the PMD plugin, which comes in IntelliJ. And here you can see the results of the scanning with the PMD rule set, where it finds several issues, several bugs. This can be very helpful. How to use it. So the JPinpoint rules, you can use the PMD plugin and download the PMD plugin in your IntelliJ and load the XML files, which comes from GitHub. And then you get the additional 60 plus performance concurrency rules. So now I want to show you a couple of examples of pains we had. And the first one is logging pains. So I've seen apps where a lot of time spent in logging, and it can really slow down your application. Here's an example of improper logging. So the unconditional execution of this line of code has an issue. So what is the actual problem here? Okay, I will give you the answer now. And the problem is actually that concatenation happens before the debug method is called. So it's independent of the need to actually log. And concatenation is relatively expensive. And it has to do some copying of character arrays, has to do some garbage collection. So that's can be quite some work. So how to solve this? Well, you can use SLF4J with the pattern, the curly braces pattern, and pass the variables without concatenating them actually. So this way, you pass in the variables, you don't do concatenation, and you leave it to the SLF4J library to do the concatenation, and only when the level is, in this case, on debug. Otherwise, no concatenation happens. Okay. And another example is, this is some code I found from a team. This is, they use actually SLF4J. However, the curly braces pattern is there. And they do still a toString of the variable what they put in. And then the problem is that irrespective of the log level, this toString is called, which may include formatting, reflection, and other wasteful processing. while it's not needed. So solution is to remove just the toString since it's already invoked conditionally inside SLF4J. And then, yeah, to show all the detection rules we have for logging. First is unconditional concat in log arguments. So there's the concatenation we discussed. Avoid unconditional build log strings. That's another one, where you see that the log statement is built for use in log debug and not in other ways. So it will detect this wasteful processing. And the third one is unconditional string operation on log arguments. And that's just what we showed, that toString is called, while you should leave that to the SLF4J framework. So next topic I want to show you some examples of is the concurrency pains we had. So I've seen crashing service, payments executed twice or not at all. Customers see data of another customer. Fortunately, this was a rather small data breach. Not many customers, but this can happen to a lot as well. So these can be really pains. And then first I want to show you this piece of code. And my question to you is for the poll, where is the bug? Okay, so hopefully all of you have answered. Yes, well, because you put in this Spring annotation service, this means that this class by default becomes a singleton. And if you put state in your singleton, it is shared among all requests. So all the state in here, that's the contract stuff, is shared among all customers. Well, this will be painful, right? So yeah, this issue came to my desk after the team couldn't find the problem, and then it went to a central team. They couldn't find the problem. So I thought, okay, let's just try the concurrency rules we have, the detection rules, to see if anything comes up. And then after tens of seconds, this is what I got. So the results of the scan just pointed me to this concurrency bug. And yeah, it turned out the team switched off Sonar because they had too many results in Sonar, which they couldn't handle at the moment. So that's not something advisable. Yeah, and this will point you to the bug quickly. So concurrency is something which is complex. It's difficult to get right. And in this case, you need to know the Spring magic. So annotations like components, service, etc., they are by default a singleton. And the question then is, do you really want to share the state with everyone? Well, usually you don't. And you can specify the scope. So in this case, session scope maybe was the good solution. And then still, you need to think about concurrency because multiple threads can access a session. Yeah, and because it's so complex, concurrency, it's important to make clear what the intention is of the concurrency handling. So what you put in your class to deal with concurrency, in case you have multiple threads accessing, well, it's a very good idea to make this clear, this intention clear. And for this, the writer of the book, Java Concurrency in Practice, Brian Getz, is known for more things, has made a great set of annotations to make this clear. So here we have an example. There's immutable as an annotation, which could have been added to the class string because it doesn't get modified after creation. And you can also use not thread safe, for instance, for string builder, because you actually change the string builder. So it's not thread safe because there's no locking there. There's no synchronized methods on string builder. The string buffer is the one which is thread safe. And here's another example. So you can add it to your class example that is thread safe. And then yeah, you can say, I want to guard my internal stuff with the this, which is the implicit lock when you use synchronized on the method. So this is how you define that. And what do they do, the annotations? Well, actually, they make the intent clear for the maintainer of the class, the developer of the class. So kind of documentation in a standard way. And additionally, the static code analysis tools, they can check for correctness, if that the intention is actually working out as promised. This is another example I have here. It's a concurrency bug that caused a painful memory leak. And I've put down a simplified version here. It was a commercial platform which was used. And yeah, because of this, the site went down several times a week for quite some time, actually. So this was really painful. And yeah, so this is an unsafe pool for you to check. And so my question to you is, where is the bug? And this is a poll again. Fortunately, I have the line numbers, which may help to define the answers. I'll go to the answer. So if we run the jpinpoint rules on it, it actually finds 3 issues. It finds has three findings. And these on these 3 lines. It doesn't mean that other lines are all correct, but this is the ones it triggers. These are the ones it triggers on. And I want to look at the first at the red arrow, the latest in the line. So the description is there. It's the finding for the second one and the third one is avoid unguarded mutable fields in objects using synchronized. So meaning there is a synchronized use in the class, so it will be used by multiple threads, probably. Otherwise, why do you use synchronized? And then it says, okay, there's mutable fields there, and you should guard them. Yeah? And yeah, that's the way to do it. And or you can make it immutable. So the first one is the map connection pool. So the hash table, that's actually a thread safe map. What can you do about it? Well, you can add final there. That means the reference cannot change anymore. And the hash table itself is thread safe. It has a lock around it. So there you solve the third issue. And as you can see, if you scan again, you only have 2 left now. 2 findings. So the one from line 9, the map is solved. And then we go to the first one, the counter. And that's another mutable field, which can, you want to avoid mutable fields because they can be changed by multiple threads in a safe way. So what you could do is maybe put this make this a volatile. Well, volatile is a very unknown keyword actually. And it does make changes thread safe, but the changes are only 1 level deep. But for primitive, that may be fine. But how do we then, is it solved? Well, we can run again the rules and see that it gives another finding. And it says, don't use the ++ or the like on a volatile field because it's not an atomic operation. It's actually 2 operations. And then threads can come in between. And then, yeah, things may go wrong. And additionally, you have multiple lines of use of the counter. So there's another issue there. So this doesn't work. When we go back to the previous situation, we need to fix this. And how can we fix this? Well, make this properly synchronized. And there you see it. Synchronize is there. And the method is made only executable by one thread at a time. Well, this should solve it, right? And actually it does. However, the tool is still complaining, and it says you should add guarded by annotation. So if we do that, guarded by this, that actually says the counter is guarded by the implicit lock we use with the synchronized method. So then this rule will check if that's done correctly. And it is. So yeah, that's really nice. We have made it correct, and we corrected the concurrency bug here. And also we have extra guards, extra checks for if the counter in this case is guarded in the correct way. So now we've solved the concurrency bug. And this way, the production issue, the outage, was completely solved. So this is what I showed you, several painful bugs which can be solved with detection rules. And then, yeah, we want your help. So please try out these detection rules on your projects and learn from the bug description. And we'd like to get your feedback. So was it helpful? What can be improved? And with this, we can grow a better bug immunity together. So understand your bugs a bit, create detection rules, and improve detection. So we have other contributors to this bug immunity, besides Rabobank, which has done most contribution. And I want to thank you for the attention. And please try it out and let us know. If you want to learn more or need help, you can see my LinkedIn page or email me at rabobank.nl. And I think there's still time for some questions.
So, thank you very much, Jeroen, for your session. Those were really interesting takeaways. Well, you dared to use the experimental poll feature on the platform, and I think it was pretty cool. You timed it really well. Great job. Almost looked like you did it live, with you standing still in the video. So maybe we can start with having a look at the polls. Were you surprised by the results?
Yeah, so it was kind of tricky to get it working, the polls. And the first one I will show if it works well. Reopen the poll I have to do. Yeah, this is it. And then share the results. Oh, the results are shared. Ah, right. This one I lost the results somehow.
Yeah, it was, yeah. Okay.
However, I do see them. But it's yeah.
Well,
So
you're giving the right answer now.
yeah, that's a glitch of the platform, I think. So let me go to the second one. Reopen, and here we should see the results. Share results.
Oh, they're also blank.
Ah, yeah.
All right.
No, there's some, right? Oh, there's just a few.
Yeah, people are giving the right answer now. Somebody did not pay attention, I guess, because everybody gave the correct answer.
And this one, try this one, the last one then.
Yeah, so they're all gone. So that's at least reliable. In fact,
yeah, well, I saw a lot of correct answers. I was happy to see that, by the way, and also some which got quite the same numbers. So people were divided about the answers, And for the unsafe pool, maybe people wonder, all first 3 answers were correct, actually. You could give multiple answers, and only the last one is, yeah, so there was a memory leak there. And well, I wouldn't stop, shouldn't put dead threads in a collection. It's kind of weird. And if you don't clear them, yeah, this obviously is really bad memory leak. But it's not thread unsafe, so that's why this one is not not one of the correct ones.
What was really funny, I think, is that some people on the chat said, well, this is really common knowledge and everybody should know this, or you're supposed to know this. And then a lot of people were also surprised by the number of people that actually got it wrong. And I think this is a lot of times the case in software development. Once you know something, you cannot imagine you doing it wrong, right? So it's first we experience sometimes these gotchas.
Yeah. So that's good to see. And yeah. I think also for me, this area of concurrency is so complex and there's still things to learn there. So I have now a bonus poll on, and if you paid really attention to the slides, there were actual bugs, pictures of bugs in the slides. So I wonder if you can see you have the number, and I can see the results already, and. So I can share them, I hope. Yes, it's working. Yeah, we can see this live. And I see some correct answers because everyone has, all numbers are picked. So the correct one is actually 8. So 8 is the number of bugs. Yeah, unfortunately, we don't have a winner. That's not a feature of the platform. It should be feature request, I think. So we can, next year, we can have a winner. Would be nice.
Yeah. All right. So there are a few remarks and questions I think we can dive into from the chat. So Nick Stolwijk says, I always learned that you shouldn't use sync on this because the outside world could also sync on that. So can you comment on that?
Yeah, that's actually well, the first thing is to get your concurrency right, so and that things are correct, and then the improvement would be to not use the implicit lock of the object, because indeed it's outside world can also use this, and especially if you work with inheritance, then the subclass has the same lock, so that's all can be very confusing. So the improved version would be to have a private lock indeed. Yeah.
Okay, thanks.
And that's all very clearly explained also in the book of Brian Getz, Concurrency in Practice.
Yeah, so there's like a must read, I guess, for any developer. Right?
Yes.
So Igmar Balsenberg, he made a couple of comments actually. In your examples, you could have also used, I think it was one of the last, you could have also used the atomic integer. And why didn't you?
Yeah, that's just one
idea that he wanted to ask. I'm guessing.
Yeah, the thing is with atomic integer, you can have like an increment and get call, and then the increment and get together is an atomic operation. But still, if you work on multiple lines with an atomic integer, threads can come in between those different statements. So the combination of those statements is not atomic.
Yeah.
So if you do it, that's the most common concurrency bug actually is the check modify. So you check for with an if it's a certain value, and then you modify the field.
Yeah.
And if it because it's two different statements, threads can come in between and the test may not be correct and not be valid anymore.
Okay.
Yeah, so that's the reason.
Okay, thanks. So Fleur asked a question I was also wondering about. While you were fixing the concurrency issues, are you then not introducing a performance issue? Because this concurrency, of course, helps us get better performance. So what do you have to say about that?
Right, yeah, so that's a thing to also pay attention to. is the lock contention which you can get. So if you have locks, if you have multiple threads accessing this piece of code, you can get lock contention. So threads having to wait to enter this critical section and to wait for the lock to be able to be acquired again. And so the recommendation is to keep these pieces of code as short as possible. So not take a long time. So for instance, don't do I/O there. Don't do a lot of computations, things like that. But in general, so if you have just a couple of statements, it's usually not a problem. And on the high load, I mean, there are other ways to, like for instance, if you have a hash map which you make synchronized, you have one lock around it, synchronized map. It's better to use specific map type for it, and that is concurrent hash map.
So we're running out of time, Jeroen. I'm sorry.
Yeah.
I guess if you have any questions left for Jeroen, please approach him through the chat function. I'm sure he's happy to reach out. So thank you very much for attending this session, and have a lot of fun with the rest of the program. Bye, everybody.
Code is everywhere. You get up with it in the morning. You take it with you on the go. It brings us closer to one another. It makes life easier, nicer, and it allows you to discover the world, make new connections, realize ambitions. It may even save your life. Nearly everything we do is driven by code. Every line you write, or don't write, makes a difference. That's why we write code that contributes to a better world, that helps shape a sustainable food chain, that empowers people to become financially self-sufficient and gives people back control of their data. Whatever you dedicate your talent to, or don't, makes a difference. The choice is yours. What difference will you make?